Hey, what's up guys? In this video I'm going to show you how to construct a confidence interval using the TI-84 graphing calculator. Now I have an example and it says an SRS of beads from a container had 107 red beads and 144 white beads. We want to calculate a 90% confidence interval for P, so that's a proportion, and we are looking for the number of red beads. So imagine that a container had more than 3,000 beads and we want to know how many red beads are actually in that container. We don't want to count all of them, so we can construct a confidence interval to estimate the proportion of red beads in that big container. And just by using one SRS, it says here we have an SRS, just one. We found that that SRS had 107 red beads and 144 white beads. So my sample size will be those two number of beads added together. So 107 plus 144 is 251. Now if you think about this SRS, which is a simple random sample, just one sample, my proportion of red beads for this sample is going to be the 107 divided by the total number of beads in that sample, which is 251, and that proportion is 0.426. Or that's a decimal, or you can say it's 42.6%. So what we're saying is that our estimate how many beads are in a container is 42.6%. But since we don't know what the actual proportion P for the parameter, that's for the actual population of the container, we don't know what it is. That's where the confidence interval will come in. So we have a formula that we can use so we can find the confidence interval, and I'm going to write it down. So the formula, you guys take your estimate. So this is called my point estimator. I am guessing just by using one sample that the number of red beads in a container, in that container, is about 42.6%. But it might be more, it might be less. So my confidence interval is going to be my statistic. So my p hat, which is the point of estimator. So I'm estimating from one sample. Remember, we got this many red beads, this proportion. So we're going to take that statistic plus or minus the critical value of the confidence interval, and we use a star, C star, to represent the critical value, and we're going to multiply by the square root of p hat times 1 minus p hat divided by n. That is your standard deviation of the statistic. So once again, we have our statistic, which is p hat proportion for the sample, plus or minus the critical value of the confidence level, and we are going to find a 90% confidence level times the standard deviation of the statistic. So we use p hat times 1 minus p hat divided by n. When you guys substitute the numbers, well, you guys can use the calculator to simplify, but there's a function that you guys can also use to find the confidence interval. But I'm going to set up the formula so you know how to where the numbers are going to go. So my statistic will be my decimal, will be 0.426 plus or minus my critical value for 90%. Now here what we're looking for is, well, what is the critical value that represents 90% in your C-score table? So you can also use the calculator to find the critical value. To find the critical value for 90%, you guys are going to go to second bars, which is going to be your distribution. D in blue is distribution. You're going to choose INB normal. So I'm going to go to number, in my calculator is number 3. And it's going to ask you guys for some stuff. So here, I am looking for the area of the C-score, the C star, and I need to use the mean of the density curve for the C-scores. So the mean is 0 and the standard deviation is 1. Now the area, we have to be careful, because to find that C star, the critical value, we're not going to use 90%. What we're really looking for is, when you guys look at the density curve, the 90% is the area in the middle of the curve. So I'm going to draw my area. So all of this area will be 90% right in the middle. We are looking for this C star, and remember that it is symmetrical, the density curve. So we do have a negative C star, a positive C star, and right in the middle we have the mean, which is 0. So we need to find one of those C stars. It's a lot easier if you guys think about the area on the left side of the negative C star. So if we have 90% in the middle, that means that the tails, these two areas, they have to add up to 10% because everything under the curve is 100%. So if we already have 90, then the two areas have to add up to 10, which means we need 5% on this side and 5% on that side, which is symmetrical. So what I'm looking for is, for the C star, or the critical value, is actually the 5% on the left side of that C star. So in your calculator, you guys are going to use 0.05, not 90, and we use decimals, okay? Never use percentages, you convert those into decimals. So that's the area I'm looking for. What is the C star that has a 5% or 0.05 area on the left side of that value? So I use this, and that is my value, negative 1.64, and we usually use 3 decimal places when we use critical values. So this 4 adds up, rounds up to 5. So I'm going to write that one down, negative 1.645, and then we have the square root of my statistic, 0.426 times 1 minus the statistic again, 0.426, everything divided by the sample size, which is 251. Now you guys can do the math. You guys can actually use your calculator to find those two values. Remember, the plus and minus means you have to separate. One expression is going to have the negative, the minus, and then another expression is going to have the plus. But in your calculator, it's going to have your actual function to find the interval. I just noticed, guys, this negative right here, we don't need it. We don't need it because this sign takes care of the negative. So that is my my mistake. I don't need that negative right there. So even though it's negative 1.645, our C star will be just 1.645. So again, we don't need that negative, we just need the plus and the minus. But that's how you find the critical value. Now, to find the confidence interval, there's a couple of things you have to understand. One of them, you have to know how many samples you are using to make your estimate. So we're using one SRS, one sample. It has an SRS of beats. So we have one sample. And what are we looking for? We are looking for the true proportion. So we have a one sample proportion. When you guys go into your calculator, you guys are going to have many options. So the way you guys find the confidence interval, you press stat, you guys go to test right over here, and there's many options: C test, T test, two sample C test. All of those are going to be used in our AP statistics class, but what we are using or constructing is an interval. So I'm going to go down where it says interval, not test. So we have a C interval, T interval, two sample C interval, two sample T interval. But remember, right now, yes, I said we have one sample, but what are we using? What are we looking for? We're looking for a proportion. So that's the keyword. My function must have a one sample proportion. So in my calculator, I need to find my one proportion Z interval, one proportion. So I'm going to choose that function. I have a proportion, and I'm using a C star, that's my critical value, and INT stands for interval. So I'm going to go there. Now, my X value is going to be the number of successes that we got in our sample. So since we're looking for red beads, that's how many red beads we got in our sample. So we put 107 for X. My sample size is 251. That's how many beads we had in that sample, 251. And I want to use a confidence level of 90. Now here, for this function, when you guys are using the one proportion Z interval, yep, you're going to use that percent for the confidence level. So as a decimal, 0.9 is 90. You guys go here, and the calculator will calculate or will find that interval. So those points, not points, sorry, those numbers inside the parentheses, that is your interval. Look at my p-hat, 0.42629. So this one is what we got, and it goes a little bit further, and the sample size is 251. So my confidence interval, let me go back over here. So all of this formula that we did right now, if you guys do the math and you guys use your calculator, you will get one number to be 0.37495, and the other one is going to be 0.47764. Even though we have parentheses, this is not an order pair, it's not a point, you're not going to graph it. What it means is our P, our estimate for the P value is between 0.37495 and 0.47764. If you guys want to use percentages, well, you guys can change those to percentages. I'm going to say 37.495% and 47.764%. Or you guys can say 37.50% if you want to round, and 47.76%. So that's the proportion that you guys have of red beads in the container. Now, when I say container, I mean the whole container. At the beginning, I said we had a container with 3,000 plus beads. So between the number of red beads in that container is between 37.495% to 47.764%. So less than half, you can say. We do have a margin of error. So remember that our point estimator, our sample, we got this statistic, 0.426, plus or minus all of this product. This is the margin of error. So plus or minus. So kind of in the middle, you guys have your statistic, and then you guys have a plus or minus your margin of error. That gives you guys the interval. So we are 90% confident, and that's what it means for the interval, the 95% confident interval. We are 90% confident that our interval from this percent to that percent will capture the true P proportion for the number of red beads in that container. So like I said, guys, in your calculator, you guys are going to have many options, and you really have to know which one you have to use, because if you use the wrong one, obviously you're going to get the wrong answer. So you have to make sense of the problem. We have intervals. For this video, I'm showing you guys how to construct a 90% confidence interval for proportions, and we're using a one proportion because we had one sample, one proportion. I hope you guys like my video. You guys can click that like button, and if you guys haven't subscribed to my channel, you guys can subscribe. You can turn on the notifications so you guys know when I upload a new video. And the only way you guys get good at math is by practice. So make sure you guys practice, and I'll see you guys later.